Welcome back everyone. For today, we will be discussing Matplotlib, a built-in package in Python that is designed to help us create a visualization. Data visualization gives us a clear idea of what the information means by giving us visual context through maps or graphs. This makes it more natural for the human mind to comprehend and making it easier for us to spot trends, patterns, and outliers. Now, Matplotlib is an amazing visualization library in Python for 2D plots of arrays. Matplotlib is a multi-platform data visualization library built on NumPy arrays and designed to work with the broader SciPy stack. It was introduced by John Hunter in 2002. Matplotlib consists of several plots like the bar chart, the line chart, the histogram, and even the scatterplot, to name a few. Before we dive into creating visualizations, there are a few useful things we should know about this package. Just as we use NP as a shorthand for NumPy and PD for pandas, we will use PLT as our shorthand or alias for Matplotlib. To import it, because it's built in, you don't need to install it, import matplotlib.pyplot as PLT. So PLT is our shorthand. It may be helpful for some of you to actually set the style that you want. So the plt.style command will help you choose the appropriate aesthetic styles for the figures. So here, with the plot that we have, it's by default the classic style. But if you want to use, for example, one of the most beautiful graphs that we are available on the web is that of the 538. So we could use the 538. We will adjust the styles as needed, and to view the available style, you can use this function. You can print the plt.style.available. And you'll see here that these are the styles that you could use to, of course, improve the aesthetic, but without it, we're using the classic one. Now, the IPython Notebook is a browser-based interactive data analysis tool that can combine the narrative code, graphics, HTML elements, and much more into a single executable document. Plotting interactively with the IPython Notebook can be done with the magic command. So anything with percentage sign or percent sign before it is called a magic command in Python. So if you have a matplotlib notebook, this one is what we will use to create interactive plots embedded within the notebook. But for now, since we're doing or we're gonna deal with static graph, it's the magic command that we need is just the matplotlib inline. And inline meaning that I want the graph to be displayed or showed inline the code. You don't need to do the plt.show. Okay, so these are usually the commands that you're going to be seeing. So let's just run that. After doing the preliminaries, it's time to create our first graph. Say, for example, you want to model or simulate the image of a wave. To do that, we will be using the sine and the cosine functions. The sine and cosine function can be used to model many real-life scenarios, including that of radio waves, tides, musical notes, or even electrical current. So to do or simulate our data, we first import numpy as np, and we create our x value from np linear space 0 to 10. So the value is that from 0 to 10 broken down into 100 points or 100 different numbers. And we first need to create a figure. This figure is, we will store the variable fig. This allows us to control the figure variable if we want to make modification. So the first one, 1y, is np.sine. So this is simulating the sine value. So basically all the x's that we have taken, we will input into the sine function to create our first y1 variable. And we want to be able to compare it with the cosine function, so it's np.cosine. It use the same x value. Now, to plot it, we just simply call on plt.plot, and usually the x values come first and your first y1. So this is your sine function, and the sine values. And the next parameters here, the next positional argument that you need to supply is what type of graph do you want. If it's a continuous line, not broken line, continuous line, then we just supply a dash. It tells Python that you want a continuous wavy line or straight line if it's a straight line, but since this is a wave, it's a continuous wave. And we can put in here the label, so when we call on the legend later, we know what chart we are referring to, or what graph. To see the cosine function in action, basically it's the same, so x and then y2, and then for the position, the third positional argument, if you want to see the broken line in action, just so that we can compare and contrast them easily, we use double dash. A double dash line would mean that you want a broken line. Let's label it cosine wave. And finally, plt.legend would display a legend so that it's easier for us to see and compare them. So basically, you've generated it here, and you see that the continuous wave line is that of the sine wave because we've used this as our parameter for the type of graph, and the double dash would mean a broken line type of chart. To save this graph, we call on the save fig method, and now because you have created a fig variable that stores the plot that you have created, it's possible for you to use this save fig. So fig.savefig. So here we will just put in here simple sine and cosine graph .png, and you'll find it here in your particular folder where you have your notebook right now, or where you actually save it. You'll find your graph being saved. Perhaps the simplest of all plots is the visualization of a single function y equals f of x. So here we will be hoping to create this type of plot, but I'd like you guys to try another style. Let's use the Seaborn white grid. In this scenario. Okay. Now, for all Matplotlib plots, we start by creating a figure and axis. So in their simplest form, it's fig, okay, plt.figure. You've seen that earlier. And ax for plt.axis. Okay. Now, we will be creating our axis, linear space, same 0 to 10, but this time we want to break down that range into 1000 points, and let's create, of course, np sine. You've seen this earlier with the sine function. So since we have created, so here it will be best practice to figures and axis first. We can now plot these two variables. Okay, so this is a simple function of y equals f of x, where your f of x, of course, is the sine function. Now, if you want to remove this line, you could basically just end your code with a semicolon, kind of like how JavaScript programmers would do it, and it would be gone. But here, in Matplotlib, the figure, which is an instance of the class.plt.figure, can be thought of as a single container that contains all of the objects representing the axis, the graphics, the text, and the labels. It's really what it's a container. The axis is what we see here in this particular graph. It's a bounding box with ticks, labels, and eventually all the plot elements that we will make up. So the figure is a single container containing all of the axes, while the axis would contain the everything related to the particular graph. So in one figure, you could have a lot of axes. Now, throughout this lesson, we'll commonly use the variable name fig to refer to figure. Okay. Now, if you want to create a single figure with multiple lines, we can simply call on the plot function multiple times. You've seen that as well earlier. And so we can as well try that right now. So x and p dot sign x. You've created one figure, but you want multiple charts to be displayed in that figure. So this is the same one as well. So cosine, right? The first adjustment you might wish to make to a plot is to control the line colors and the styles. The plt.plot function takes additional arguments that can be used to specify this. So let's just get this to adjust the color. Okay, so let's have the default first here, and so that we could compare the different adjustments that we will be doing. So let's say, for example, here we'll create another function and let the color be blue. So you could specify that with the parameter color, and your input would be the color name. So in this case, it has become not the default blue, okay? And in this case, it's actually the same as this one. So maybe you want to get this here, okay? And you could also specify your color, the answer to this parameter, or the input to this parameter, with the short color code. So for example, for the RGBCMYK, you could have it here. So, and let's say gray, you want gray, and you'll have, or sorry, green rather, G is for green, and grayscale from 0 to 1. So let's say here, so grayscale 0 to 1, and let's change this. So 0.75. So you have that there. Or you can specify it using the hex code. So let's say it's FFDB44. So basically you could just search it online. Or you could, oh, okay, maybe you want to see that action before. You can also use RGB, which is tuple. The input here should be a tuple. So let's make it 5. And let's say our RGB code would be 1.0, 0.2, and 0.3. Okay. So there you have it. And maybe just we're having a lot of values here. Maybe just compare this one first. There you have it. Okay. And last one, we could have, you can also supply HTML color names. So let's do that here. And the color is chart reuse, which is an HTML color name. Oops. Okay. Now, if no color is specified, Matplotlib would automatically cycle through a set of default colors. Similarly, you can adjust the line style using the line style keyword or parameter. So, let's use a different chart. Plot x and x plus, for now x plus 0, and let our line style, so this is a perfect diagonal, right? Solid, passing through the axis. You'll get this, okay? Now this is similar to the continuous line. If you want it to be dashed, okay, good, have it dashed here. Okay, you can likewise have dash dot. Okay, dash dot, and you can have dotted. For short, you could easily use the following codes to achieve the same level of modification in your line style. So for the solid one, you've seen this earlier, it's just a dash. Okay, you have that. And for the dashed one, you have this double dash. Okay, and for the dash dot, well, from the word itself, it's actually very intuitive. It's a dash and a dot, and of course for the dotted, you can have this colon. And there. If you would like to be extremely terse or sparingly use a lot of words in your code, well, you can combine the line style and color codes into a single non-keyword argument to the, of course, PLT plot functions. So let's say, for example, for this one, we can get this and try it. Let's say after this, you want this line to be green. Okay, so just to see that in action, this is the line style, and then the G is from the, well, the solid green. We've seen that, we've used that earlier. So here, okay, it's the error here. It's not even, okay, so there needs to be, okay, you have to remove the line style because it's no longer a line style, and just put in here G. Now for this one, for example, if you want this to be cyan or dashed cyan, okay, don't use the line style argument as well, but just a positional argument of the third position here in this argument, and want to make it a dash dash cyan or dash dash C, with a cyan dashed line. If you want a dash dot block, okay, a dash, so this is the dash that, right? And then black is K, value of K. And finally here, for the dotted red, don't use the line style argument, make it a positional one, so you know that already from my functions video, and put in red. Okay. Now, the single character color codes reflect the standard abbreviations in the red, green, blue, and CMYK, or the cyan, magenta, yellow, black color systems, commonly used for digital color graphics. So if you want to verify or to change colors, you should bear in mind that they are the standard abbreviations from those two color systems, RGB and CMYK. Matplotlib does a decent job of choosing the default axis limits for your plot, but sometimes it may be nice to have finer control. So the most basic way to adjust your axis limits is to use the plt.xlim and plt.ylim methods. So let's see that in action here. So plt.plot, so we'll use it for the sine function. So we have lp.sine x, for example, and so you could see that Matplotlib chose the specific axis limits. These are your limits for your x-axis. These are your limits for your y-axis. But if you want finer control, let's say, for example, you want to adjust it, then you could use the plt.xlim or xlimit, where you're saying that you want your limits for x-axis to run from -1 to 11, or these are your two limits. This is your lower limit, this is your upper limit. So to see that, you'll have it here. Okay, so your x limit now, you have your -1, and this is 11. It's actually nice because you know what, for sine graph it's continuous anyway. So for the y limit, let's say for example you want this to be a little bit more centered, then we'll use the plt that y lim, and maybe let's say negative 1.5 to 1.5. Okay, and you've seen that now your y limits have expanded. Okay. If for some reason you'd like either axis to be displayed in reverse, you can simply reverse the order of the arguments. So let's say in this case, one, and now it's in reverse. Okay. A useful related method is the plt.axis. So note here, so it's a plt.axis. There's a potential confusion, so I'd like to let you know that the first one that we've used is the one with the letter E. It's axis, right here. It's axis, but this one, what we're teaching right now, is the plt.axis. The plt.axis method allows you to set the x and y limits with a single call. So by passing the limit that specify x mean, x max, y mean, y max. So this is how you do it if you want to set your x and y limit individually. But if you want it to just be in one argument, you could use this, negative 1, 11, negative 1.5 to 1.5. But maybe we want to see it, let's differentiate this, okay? So basically the argument is here, it's x mean, x max, y mean, y max. And there you have it. So, oh well, because we need to plot so that you can see. And maybe you'd like, okay, so there you have it. Last for this lesson on line plots, we'll briefly look at labeling the plots, like titles, axis labels, and simple legends. So titles and axis labels are the simplest, such that there are methods that can easily be used to quickly set them. So let's again just practice our plotting here. X. And the method is quite simple and intuitive, just title. So here we could have a sine curve. To label the x-axis, it's also intuitive. We call on the x label. Okay. So here we have the x values, and maybe the y-axis, it's just the y label. And maybe you want to be a little bit more fancy here. You could just say y equals f of x equals sine of x. Alright, so let's put the semicolon, and there you have it. It's labeled properly. Now you can adjust the position, the size, then the style of these labels using the optional arguments to the function. You already know how to do that. It's just the help. Let's say, for example, plt.y label. So these are the, for example, the location where you should want to put them, bottom, center, top, and there are other modifications that you could use with the text. But for now, we'll just go with the basics. With multiple lines are being shown within a single axis, it can be useful to create a plot legend to label each type, so similar to what we've done earlier. And Matplotlib has this built-in way of quickly creating such legend, which is, again, as intuitive, plt.legend method. There are several valid ways of using this, but it's easiest to specify the label of each line using the label keyword. So let's briefly see that again. So it's plt.plot. So that it'll go into the legend. If you use the label function, the legend will quickly catch on. So let's say x and then np sine, np.sine of x. Okay, and the label will be sine of x. So here we have the cosine and cosine of x. To ensure that the legend is displayed, we use plt.legend. Okay, and you'll see that the legend is here. Now you can, for example, for this video, if you want to change the location of that legend, maybe you find that it's better if it's in the top left, for example. So there is an argument that you can pass on into that function. So I think here it's the lock. Okay, maybe you want it in the upper left. So lock is upper left. In that case, you see that here. Now, this is where your training earlier will be used, where you can set the limit so that it's in the upper left, or it's not well coinciding or making your graph look cluttered or dirty. But basically, upper right or lower right. And finally, this one has an intuitive ability to find out the best location, where you would just apply the location to be best. Determine the best place. And as we have already seen, it will put it in the lower left because that is where it is not intersecting or making the graph dirty. Another commonly used chart is that of the scatter plot. It's a very close cousin of the line plot. Instead of the points being connected by line segments, here for the scatter plot, the points are represented by a dot, a circle, or maybe a triangle, or any other shape, and we'll see that later in action. In the previous section, we looked at plt.plot and ax.plot to produce line plots. Well, it turns out, using the same function, we can produce scatter plots as well. So let's see that now in action. So x p line space 0 to 10, and right now let's just make it 30 points, because if it's too much you wouldn't see the points. It will just look like it's one regular wavy line. Okay, and then y b and p dot sine x and plt dot plot. But instead of the terse arguments that we used earlier for the dash or dash dash or dash dot, you can just input here for the third positional argument O, which is simulating dots, right? Color is black. And this is a simple scatter plot. Now, this third argument here in this function represents a type of symbol used for plotting, and you've seen that earlier. So if you use, let's say, for example, even plus, you can make it into like crosses or pluses. And I think you can even use this, right? So for the triangle, so let's maybe, for example, you want it for to track your KPI. Triangle is usually what's being used. And of course, maybe for example, they're all positive, green, or they're all negative, it's red. Okay. Now, to fully appreciate this one and to see whatever what else we can have, let's try to add this. So it's RNG is NP. So please code it with me. It'll be very satisfying to see whatever output we have here. Let's make it random state so you guys can replicate it. For marker and or the available markers, you have the O. If you're wondering if we have the dot, yes, we have the dot as well. We even have the comma. We even have X's. You've seen this already. You have plus. You have as well the caret sign. I think even the letter V, kind of like the inverted caret. You can even have this, the less than sign, the greater than sign. Okay, maybe we can have the S sign as well. Okay, see that what that is, and of course the D, 3D. Okay, To see how this looks like, we'll plot the following. Okay. RNG.rand5, which is a random state, okay. And just to create random points, okay. And the marker, so we'll iterate through this, we'll traverse this list, okay. And of course, we want the label, we've seen that earlier, label to be marker, okay. And we'll put in here the format of the marker so that we'll know how they look like. And here for the plt.legend, let's apply the num points argument with 1 and let the limit be 0 and 1.8. Okay, there. So you'll see here, S is for square, D is for diamond, and basically you can have multiple types of markers in your scatter plot. For even more possibilities, these character codes can be used together with line and color codes to plot along with a line connecting them. So for example, maybe we want plt.plot similar to what we have earlier. It's x and y, and here you want a line that connects every dot, and you want them to be of color black, for example. So in this case, this is how you read it. This is a solid line with a circle marker and a black color. So if we plot that, you see that here. Maybe you want it to be green, that will be green. If you want this to be well, dashed, connecting to that circle, and maybe because the circle is not as clear, maybe you want it to be of a caret sign, so you can have there, or maybe a diamond for D. Okay, so you have it. Okay, but of course you could separate the plot for this one. Okay, so if you have, maybe you want a different color for the scatter or the points, so it's basically just this and red. Okay, so that's how you do it. So of course, as a programmer, it's still best if you would use the keyword arguments for readability, but the terse arguments work as well as long as you know how to read it. Now, additional keyword arguments for the plt.plot specify a wide range of properties for lines and markers. So, for example, for this case, we can make this plt.plot. Oh, but let's review first. What are the arguments that the keyword arguments that you could use to edit the properties? Okay, so you have a lot here, right? So please go through them, but we'll use some now to make our graph or plot more beautiful. So it's the x and the y, and let's make it that it's p. So okay, so sorry, we didn't use p here, right? But p is pentagon, so could basically use p as well. And let this be of color blue, right? We want the marker size because, for example, in this case, if you want the triangle to be a little bit bigger, you want to input the marker or control it with the marker size argument of 10, for example, and the line width, for example, you want this to be thinner or thicker, then you could use line width, maybe equate it to 2. The marker face, okay, marker face color can be yellow. Okay, so that would be the color inside your marker, and we've chosen a pentagon marker. Okay, marker edge color for the edge surrounding that marker, maybe let's make it red, and the marker edge width if you want to control the width of your marker, and let's make it maybe make it to 1. For now, let's make the limit for x so that we'll be able to see, or sorry, the y, we'll be able to see that in action more clearly. 1.2 to 1.2. Okay, blue is not defined. Okay, so there you have it. So as you could see here, the blue is the line, okay, and the marker size here, it's bigger. If you want it to be even bigger, maybe you can try 15, right? So but it's now doesn't look as good as the one earlier, so maybe just make it 10. The line width here, maybe if you want to maybe just make it a default of 1, you can do that, or maybe thicker, you can do that as well. The marker face color here is yellow, but you could totally make it, for example, green, but I think yellow is better. And the edge, okay, the edge is this one, right? The edge of your marker, and of course your edge width. So maybe let's say, for example, the edge width would be let's say 6. It's, now the edge is too thick, okay, and we don't want that, so just 1. Okay, so maybe the line width can just be 1. There, I think that's a little bit better. Okay, this type of flexibility in plt.plot function allows, of course, for a wide variety of possible visualization options. So I do recommend for you to just review your plt.plot documentation to improve your aesthetics here. A second more powerful method of creating scatterplots is through the plt.scatter function, which can be used very similarly to the plt.plot function that we've tried. So let's see that in action. So plt.scatter. Y, the marker is equal to. So here we've basically achieved the same type of chart that we used or we have created using the plt.plot. Now the primary difference, of course, you might be asking, the primary difference of the plt.scatter from the plt.plot is that the plt.scatter, this function, can be used to create scatter plots where the properties of each individual point, the size, the face color, the edge color, can be individually controlled or mapped to the data that we have on hand. So let's show this using a random scatter plot with many points and many colors and sizes. So in order to better see the overlapping results, we'll use the alpha keyword to adjust the transparency level. So similar to what we have earlier, it's np.random state, and we'll create 100 points. It's capital R. For those of you who wants to see what X is, so that's what X contains, and will contain as well Y, or will create as well Y. Okay, and we'll have different colors for this different pair of points. Okay, so we'll use the rand function here, right? Not the rand n. For the sizes, we can multiply it with rand n, right? For example, here for the size, and if you want to check what the sizes contain, okay, so we can do that, scatter. And here is what we mean by you can directly map the properties to the data, which is much easier with plt.scatter. So you have the X, and then the Y, and then the C will be the colors, assuming that, of course, that you have different lists or different numpy arrays for those. The sizes will be, of course, S argument will be the sizes. And to better see it, we'll use the alpha keyword for transparency, and you can have here the color map for Viridis. Okay, sorry, it's V. We'll also use the color bar so that we'll see the color bar, kind of like the legend for the colors. We display this one. Okay, so there you have it. So this is the color bar. So notice that the color argument here is automatically mapped to a color scale, shown here by the color bar command, and the size argument is given in pixels. In this way, the color and size of points can be used to convey information in the visualization in order to illustrate multidimensional data. So there will be data of yours that has different dimension, and if you just want to use a scatter plot, the color can be an aspect, maybe it's a category, and the size can be the magnitude of that. And you often see this, let's say, for example, in visualization of magnitude of earthquakes, for example. And we can use it for a data set that's present in sklearn or scikit-learn, where I think that's the iris data set, where each sample is one of the 3 types of flowers that it has size of its petals and sepals carefully measured. So to do that, we'll import that right now from sklearn, that data set. So let's use it with a data set, and let's import load iris. And the iris data will simply be what's the output from the load iris function call, and let the features be iris data. So we'll create a scatter plot, and the features will be first one, and that will be the x value, and then for the y value here, it will be the second column or second dimension, and then alpha is 0.2 for transparency. Let the size be equal to 100 times features 3, okay, and let the color be iris.target. So you'll see here that the color is a categorical type, and the scatter plot will map it automatically. And then the CMap can be where it is. If you open the documentation as well here for the plt.scatter, you might or you will see the other color map that you can use. And we'll add a label. Okay. And the label will be the iris.feature names. I recommend you guys check this out for yourself, even without putting it in the X label and then the Y label, and the feature names for the Y label will be Y. Okay, so it's loading. Has 4 points. Okay, so features 0. Okay, it's not what we want here, it's just features. So I think we have to transpose this. Sorry, we have to transpose this first. Okay, so if we transpose this, now we'll have this, and if we get the first one, it's just this. Okay, so that's where we're wrong here. Okay, so there. Now we can see that this scatter plot has given us the ability to simultaneously explore 4 different dimensions of the data. One, the XY location. You could see this is a different flower, this is probably a different flower where it has a wider range, and this is a different flower. So it's the location, X and Y, of each point corresponding to the sepal length and width. The size of the point is related to the petal width, and the color is related to the particular species of flower. So multicolor and multi-feature scatter plots like this can be useful for exploration and presentation of data. Now let's talk about histogram. A simple histogram can be a great first step into understanding your dataset. So just as with scatter plots, Matplotlib can also create basic histogram in one line, once of course your normal boilerplate imports are done. So let's visualize it now. So we've already imported the magic keyword of Matplotlib inline, numpy, and Matplotlib. here we want the seaborn white instead. Now let's create our data. It's from the random. Function. And to create a histogram around it, just simply input that as a parameter for the plt hist function. And easily, you'll get a histogram or a distribution of data because the random number has a mean of 0 and standard deviation of 1. It's no surprise that a lot or the center of this data is actually clustering around 0. The hist function has many options to tune both the calculation and the display. So, for example, you might want to check all of that here with the help function or the normal question mark after the function. Sorry, help function. And we can basically try to edit this particular graph using some of the parameters. So let's try that now. So let's say, for example, the first argument is the data, and maybe you want to control the number of bins. So let's say, for example, you want it to be 30. You might as well want to have the color to be transparent, so the alpha 0.5. If you want a density kernel to be estimated around it, you just input true to the density parameter. Maybe for his type, we can use step filled, and maybe use the color red for the fill of the bar, and edge color to be green. So using the same data, this one, we have modified it to look like this one, and the benefit of having more bins, as you could see, is that now it's clearer that the center of this data is really in around 0. But in this particular case, you could try to experiment, and there are a lot of literature around what would be the appropriate bins and how to choose it. But if you ever decide on that number, a parameter or an argument for histogram would be available for you to tune it. The PLT hist docstring has more information on other customization options, and I find this combination of hist type or the histogram type step field along with some transparency of alpha to be very useful now, especially if when you're comparing histograms of several distributions. So this is just one distribution, but let's say, for example, you want to compare the distribution of 3 different population, then the step field and alpha would work very well. Let's try that now. So for example, for x1, create that normal. Okay, so we supply a different input here, mean, standard deviation, and occurrence. And for x2, and for x3, so let this be our 3 population, and let our keyword arguments be the following. So like what we've been doing earlier, we can plot 3 histogram in one figure just by calling the PLT hist in the same line of code. Here we unpack the quarks. So if this is your first time experiencing this, note that two asterisks before quarks or a dictionary means we are unpacking it, or all of these items are being input here. Okay, and basically we do that as well for his2 and history. Okay, and maybe put it here so that we could see. As you could see, the combination of the his type step field and the transparency count or value allows us to better see the areas or the points where they intersect, and where a lot of this three population have their points overlap, where most of it is centered. Now, if you would like to simply compute the histogram, that is, count the number of points in a given bin and not display it, in this case, the np.histogram function is available. So we have here the plt.hist, but now we'll be learning about the np.histogram. Okay, and you have the data, which we've simulated earlier. And let's say, for example, you want how many data falls into several bins. So you'll get something like this one. So you have 75, 368, 438, 114, and 5 for each of the 5 bins. Okay, so, and sorry, so to better represent that, maybe you can just put it in count. Sorry, the other one is the bin edges. The edge meaning the start and the end of those bins. So because you have 5 bins here, your edge should be 6. So to print the edge, bin edges. So there you have it. Finally, for this video, we'll discuss the bar chart. A bar chart is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values that they represent. So these bars can be plotted vertically or horizontally. Now, a bar graph shows comparisons among discrete categories. So one of the axes of the chart should show specific categories being compared to, and the other axis represents a measured value. So let's try that now. In this case, let's first create a fig. It goes without saying that we should be doing this for every chart, but we have that earlier. So we have the courses of C, C++, Java, Python, PHP. And let's say our students are okay. Now, first argument here are the category, the discrete categories, right? And the second positional argument for the PLT bar is that of the values. So now let's say, for example, we want to turn this into a horizontal bar chart. We simply get this one, the plt.bar, or maybe just modify it here so that we'll still have the fig, because it's important for you to always have this. It's bar and then H. But in this case, it's still going to be the categories and the values. And now, you've effectively turned this into a horizontal bar chart. When comparing several quantities and when changing one variable, we might want a bar chart where we have bars of one color for one quantity or value. So let's say, for example, let's do something like this. So it's a nested list. Okay, and we want to create a large x. Our x value would be 4. Okay, and of course this. Okay, so in this case what we could do is to give for the first category so that we will move it need a 0, so that will be the Y. Let the color be here be blue, and the width, so you can see here you can control as well the width 0.25. For the next bar, using the data 1, good, move it, so let's say 25, and let's say here the color will be green, and you're seeing the pattern here. We'll just add here 25, so this will be 50, and this is for the data 2. We'll make this red, so there. And after achieving this, you could likewise look at the other parameters available for the bar, where you could unpack the keyword argument here and maybe put in some labels above, and of course hide or show the axis, for example the X and the Y axis, or maybe even put a legend here. So that's it. And that's it for this course on Matplotlib. Hopefully you'll be able to use Matplotlib to uncover the patterns by looking at your data points visually. There's another video here in this channel where I discuss the basic principles of data visualization, such as when to use one type of chart over the other, and like for example for the bar chart, when to use the horizontal bar chart or the vertical bar chart. I encourage you to view that video as well, so that you would be able to incorporate those principles into your design and the aesthetics for your visualization. So hopefully there are a lot of packages that you could still try. So Seaborn, for example, is also really beautiful, and there are a lot of interactive graph. But for basic exploration of data, Matplotlib does a very decent job. Hope you enjoyed the content. Till the next video.